Hello everyone, we will do one lab. Okay, we will do one lab for the OSPF. So let me go here. Let me stop this router and create a new lab. So how we can stop? We need to go here, close this lab. Okay, and we can take any lab here. I have OSPF some lab, but anyhow I will create new lab here. Create here, add a lab, and then we will write here OSPF. Okay, OSPF. I will write basic lab here. I will create, and now I will take some router. We can take any router. I will take same thing, this router. I will take two router, and name I will give as a R, and here interface I will select the same this interface. I need one is sufficient, but anyhow increase. It will consume half GB RAM. Okay, one router will consume half GB RAM, so two router will take 1 GB RAM. So I will connect like this. Now what I will do, loop back. You have the doubt for the loop back, so here we will create the loop back. Okay, let me, maybe I lock this one or no. Let me move here. So now I need to attach this to switch or attach to any other router. So instead of attaching, I will create here loop back. I will give as a loop back here. So I will write loop back. LO is nothing but loop back 0, and I will increase this font size as a 15. I will create this one as a bold, and let me give this color. So let me assign IP also. Here I need to assign IP also, so I will give here, I will give IP as a loopback 1.1.1.1. okay, I am giving 1.1.1 for this router. Let me make duplicate of this one. I will move this here. This is the router 2, so I will give here loopback as 2.2.2. 2.2.2. okay, let me start this router, so it will load and it will be ready till we finish the IP schema. And here in between we can give any IP. I will give here, or if you want I can give like 192.168.1.1. this will be this interface. We will have this IP because I am using only two routers, so I will use this way. And 1.2. we need to remember this IP and this IP means this interface directly connected interface should have the same subnet. They should in the same subnet. Like if you are using here, how we will identify same subnet or not? This is a /24, means this is a network. So this all N should be same here and here. This is a network. So this is 192, okay, correct. 168, correct. 1, correct. This can be changed, okay. But if I use 16 means we should match to only two, this first to do. That means same subnet. If we don't have in same subnet, it will not form the neighborship. Later we are going to see that one also. Now just I want to show you how we can configure. So I will start this router, and we will write no here and press enter and wait. And let me go to another router. I will start this router, and here also I will write no, and I will wait. And what I will do, I will let me save this configuration, then we can open another notepad to do the configuration for the OSPF. So let me save this, and let me create a new notepad. Okay, so let me do basic OSPF configuration, basic OSPF lab. Same thing as we do before for other routers. Enable config t host name R1, and then we need to assign IP interface fast Ethernet 0/0. I will write 192 fast Ethernet 0/0 IP address 192.168.1.1 255.255.255.0, and we will write no shut here. Okay, and we have another interface. We have the interface loopback 0. This way we will give loopback 0, and then we will write IP address. What is the address? We give 1.1.1.1 and 255.0.0.0. Okay, this is a configuration for R1. I will copy the same configuration, I will paste here, and I will divide in between them here. This is a R2 and this also R2, and if you see what IP we have, 1.2, so this should be 1.2, and here we should assign 2.2.2.2. okay, any doubts still here? I hope nothing, right? Because this is just simple, just we assign the IP. Now let me copy and paste this configuration in the R1. So I will go in the R1, and in the R1 I will paste this configuration. I will paste here. Okay, no error, nothing, everything is good. Then I will go here, I will copy this whole configuration from here, and I will paste this in the R2. So this is our R2, just I will paste the configuration here. So this is also okay, no error, nothing. I can save the configuration here, WR, and I can save here also the configuration WR. Let me go here and save the configuration. Now we need to do the OSPF configuration. So let me write here directly, first of all here, then we will do in router also. So we need to write router, OSPF, and the process ID. First we need to write router and then OSPF, and there is a process ID. Process ID we can give any number starting from 1. There is a lot of number, we can write anything. I am using 1 here, and it is not necessary if you use 1 here, it should be used 1 here also. It is a local significant to the router. If you use the process ID here as 1, you can use here as 2, or if you want to use 1, you can use 1, no problem. Okay, this is only local significant to the router, means here only it is available. If you use 1, 2, 3, no worries for OSPF. But if you are using EIGRP, that is we are calling AS number, both sides should be same. If you use 1 here, here also 1, where in EIGRP, but in OSPF you can use anything, whatever you want. So this is a process ID. In OSPF we are calling as a process ID, in EIGRP we are calling as a AS number. So now what I will do here, first thing we write router OSPF 1, and we need to define router ID. We can define, or if we don't want to define, automatically router is going to take the router ID. We are going to check that one later. After that, what we need to do, we need to write network and network ID. What is the network ID of this one? We need to activate the OSPF to this interface and this interface, these two interfaces. So we need to calculate the network ID for this one. How we will calculate? Just now we learn. This is a 255 means N, this is 255 N, this is 255 means N. So these three are N. So we need to keep that one. And wherever H, this is a H, we can make 0. So I will make 0 this one. So what we will write? We will write network, network ID, and then wildcard mask. What is the wildcard mask? Opposite of subnet mask. Or you can subtract from the global subnet mask. But this is easy directly. Wherever you have 255, you can make 0. And wherever you have 0, you can make 255. So I will write 0.0.0.255. Then after that, we need to write area. And whatever area you want, you can write. We will write area 0. So this interface will be in the OSPF. When we do this one, this is a network command. We have two methods to configure OSPF. We have two methods to configure the OSPF. One is network command. The one which we use, this is the network command. Another is a interface method. In the production network, we are using interface method only. In the real scenario, we are using this method only. But you should know both method. Okay. So first lab we will do the network commands. Second time when we do the OSPF lab, we will use the interface method. But you should know both method. So what we done here, we write router OSPF 1, and then network ID, and then wildcard mask, then area 0. With this one we enable the OSPF on this interface. When we write this network ID, OSPF will check which interface this network is assigned, and he will enable that interface. In this interface, OSPF will enable. Now I need to enable in this here also. So what I will do, I need to write same thing. So I will copy this same thing here. I will write here network, and this is a network ID. What is a network ID here? This is a class A IP. So we will have only one, remaining will be 0. So I will write 1.0.0.0. And then what is the wildcard mask? First will be 255, remaining will be 0. That means remaining will be 255.255.255 and area 0. This way we will configure the OSPF. As per our syntax, if you see here, what we done, we write router OSPF. This is a process ID. Network ID, wildcard mask, area 0. Network ID, wildcard mask, area 0. If you have 4 interface, you will write again network ID, wildcard mask, area 0. Network ID of the 4th interface, wildcard mask, area 0. Okay, so this way we write here. If you see this one, same method we follow here. This one, then the network ID and wildcard mask, area 0. So now what I will do, I will copy the same thing from here and I will paste here, because we need to do for this also, right? So if you see here also 192.168.1.2, so this will remain same, because I need to calculate the network ID, so I need to make this 0. So this will be 192.168.1.0, and here I need to make this as a 2. Okay, network ID will be 2.0.0 and wildcard mask will be 0.255.255.255, area 0. So this way we will write the OSPF configuration. So now I will copy this one, I will paste in the R1. Let me go to the R1 and let me write here in the configuration. I will go and I will paste the configuration here, and let me copy the OSPF configuration for the R2 and I will paste this in the R2. So this is the R2. We will go in the R2 and here's okay, we need to go in the global configuration mode, then we can paste the configuration. So I am here in the global configuration mode, I paste the configuration. So we need to wait, they will have the neighborship, they will exchange some packets. We have the 5 packets in the OSPF, we are going to discuss that in the coming classes. So they will form the neighborship, then we can have the route. So what we can do, we can write here show IP route to check the routing table. Still we don't have any route here. Okay, this is only our information and directly connected information. We need to get 2.2.2 in this one, and here if we check here show IP route, still we don't have show if you see, now we found this urgency here and here also, and they move from the full state, from the loading to full. What is loading, what is full, we are going to check that one later. So now they have the neighborship. We can write show IP route. When we write show IP route here, you have the one route from the O. If you see, O is nothing but OSPF. So this route we learn from the OSPF. And what is the OSPF AD value? 110. And here is the metric, that is cos is 2. Later we are going to check how we have the cos 2. And this is a interface. This is the interface. If we want to go to 2.2.2, we need to forward the traffic to this interface, and from this much of time this route we learn, and this is our leaving interface. If you want to check directly like OSPF only, we can write this way. So you will get only the route what we learn from the OSPF. And if you want to check some more thing, show IP OSPF neighbor. With this one we will check the neighbor table. This is R1. We are getting here neighbor ID as a 2.2.2. Who is 2.2.2? Our neighbor. Who is our neighbor? This guy. I am standing here R1. I am checking the neighbor table. So when I check the neighbor table, what I am getting here? I am getting this one. This is the router ID. So here we are getting router ID. By default priority will be 1 and state is in full, and this guy is a DR. And if you see, this is a dead timer, and this is the IP address of the neighbor. This is our neighbor, and neighbor router ID is 2.2.2. How router ID we did not configure. Later we are going to look how we can configure. We are going to check. Now we have 2.2.2 as a router ID, because whenever we have the loop back, automatically router is going to take the loopback IP as a router ID. So we have the router ID here, and we can say priority and the dead time, and this is the IP of our neighbor. This is our neighbor, so his IP is this one, and the interface. And now we can check the other table. What is the other table? Database table and topology. Some guys are saying topology table, some guys are saying database. Show IP OSPF database. Show IP OSPF database. So with this one we will get the database table. So here what we have, this one OSPF router with the router ID 1.1. This is our information. We are in the R1. So our router ID is 1.1.1. How we know? We did not configure the router ID here, but we have the loopback IP. We have only one loopback. That IP router is taken as a router ID 1.1.1. And the process ID we told we write 1. We can write 2, 3, anything we can write. I will show you that one. And then this is router link state area, we use 0, and this is a link ID, that is a router ID, and the guy who advertised that link, he is that ID. So this router and this router advertise, so they both router ID will come here, and this is the age and sequence number and how many link they are advertising. This guy is advertising this one and this one, so 2 link they are advertising, 2, and this router also advertising here 1 link, and this is 1 link, so 2 links. And this network link states here our router information. This one is the our neighbor information, what we learn from the neighbor. So neighbor information, neighbor ID, router ID, age, and the sequence number. And if you see this one, this is a process ID. I will show you because I copy paste, so I cannot show that time. Let me show now. I will go in the configuration. I will write router OSPF, and if I press question mark, I have this number. This is known as process ID. We can use 1 till 65535 in this router. Generally we use 1, but we can use 1 or any number in between this one, including this number. And if I use 1 here, if I use 2 here, no problem, it will work also. But now in this configuration we use 1 here also, here also. So in the Cisco router, if we have any confusion, just write the command and put the question mark. He will show you all other option whatever is available. So this is a basic lab just to check the OSPF. This one what we discussed, how we can configure and how we can check the tables. We have 3 tables. Okay, so let me stop this recording.